I'm continuing a video series that I started a little while back to update a video I did a long time ago about low pin count buses, PCI buses, ISA buses, that kind of thing. And I talked about the ISA bus in one video, I talked about the PCI bus in the next video, and now we're going to talk about the low pin count bus in this particular video to correct what I did wrong way back when. Okay? And so here we go. Alright, now then. Now, so far I've done my very best to explain how a computer bus works. Remember, we're talking about electrons flowing over copper, and not copper wires as you would understand the term. It's more like copper plating, and I showed you this once before. You can see right there. You can see some copper plating right here. Okay, and that's where electrons would run. Okay, and for each little line here, one electron would flow across that little line. That's why you have so many of these little lines, because if you wanted to send 8 electrons, you'd have 8 lines. 16. If you want to send 16 at once, you have 16. So, but this process happens super fast. So as you're sending electrons across these copper plating things here, and I did explain that in my PCI bus video, it's traveling super fast, and the thing is that the more modern boards make it possible for those electrons to move even faster. Okay, so these things are moving at breakneck speed here. You couldn't even watch it with the naked eye. That's how fast these things are moving. And so that is what's happening here. You have these low pin count buses which are sending electrons from your memory or wherever else they're sending it from to your CPU, and then the CPU sends it back along those same lines in the opposite direction. You can send it to your memory, it can send it to your keyboard, it can send it to your mouse, so on and so forth. There you go. Okay, so like I said, that you saw those copper lines. Each one carries one electron, but that electron moves very fast. So therefore, when it's sent the first electron across, it's so fast it can then go ahead and send a second one, and a third, and a fourth, and it travels. It's super fast. That's all I can say. It's just super fast. Now, how fast these bits? Because remember, these electron particles represent bits. Okay, how fast they're sent is determined with a megahertz measurement. If you see 8 copper lines connecting one computer chip to another, then you can send 8 bits from one chip to the other at the same time. If you see 16, it sends 16. If you see 32 or 64, it does the same thing. And I actually have a web article that explains this a lot better right down here in the description below. Okay? Now, let me show you how this works. Okay? And if you go to computer class, you'll learn this right away. You have 1 byte equaling 8 bits. 1 byte equals 8 bits. That's the way it works. If you have 2 bytes, that's 16 bits. 4 bytes is 32 bits. 8 bytes is 64 bits. And so on and so forth. You get all the way up to 128 bytes, which is 1024 bits. Okay? Now, what is a byte? Okay, it's real simple. A byte is like 1 character of the alphabet, or you'd have a combination of 8 bits representing a number. Okay, like it would be called a digit. Okay, so you'd have 8 bits representing a digit. Well, the number 1 is a digit, so it's 2, 3, 4, 5, 6, 7, 8, 9, and 0. Okay? All of these numbers here are what they call digits. Okay? and 8 bits represents each one of those digits. If you want to look this up in what they call the American Standard Code of Information Interchange, you can look that up for yourself, and you'll see that there are 8 bits that represent 1, 8 bits that represent 2, and so on and so forth, all the way to 0. You say, well, what about if you have the number 10? Well, if you have the number 10, you actually have 2 digits. The 1 is a digit, and the 0 is a digit as well. Okay, if you have the number 12, the 1 is a digit, the 2 is a digit. So you would have 8 bits representing the 1 and 8 bits representing the 2. And that's how that works. Okay, but it goes on. What if you've got a kilobyte of information? Well, that's 1,024 bytes, or 8,192 bits. That's a big number. How about a megabyte? Well, that's 1,024 kilobytes, or 8,192 bytes, or 65,536 bits. That's an even bigger number. Well, what if you have 4 megabytes? Well, that's 4,096 kilobytes, which actually turns out to be 32,768 bytes, or 131,072 bits. Yeah, you mathematicians out there, you know what I'm talking about. Okay, so what about low pin count? We've covered just about everything else here. Let's cover low pin count, shall we? In 1998, there were still a lot of ISA graphic cards and sound cards that were still operational. People who owned the newer personal computers knew that they would eventually have to replace their ISA boards with PCI boards. But they didn't want to go with their ISA boards right away. That's because people still owned IBM PS2 keyboards and mice that still function. What are they supposed to do about this? Well, I have some web articles I'd like for you to read about this. But this is where the low pin count bus actually comes into play. Okay? The low pin count bus is actually what they call a software bus. This bus works differently than a physical ISA bus. The low pin count bus software requires less pins to send and receive information from peripherals than a typical ISA bus. This makes the LPC bus operate a lot faster. But this LPC bus software also works as a translator. It can communicate with an ISA bus peripheral, like a PS2 keyboard or a mouse, using old instructions while communicating with the CPU at a faster speed. So, not only does this low pin count bus allow communication between a PS2 keyboard or a mouse, but it can translate instructions. Say, okay, this CPU is more modern. We have to tell the CPU that, gee, we've got a PS2 keyboard, and to read the keyboard in a certain way. And that concludes my low pin count bus video. However, in the not too distant future, I am going to go ahead and do a video series on USB, and I'll go into what the acronym actually stands for and the whole 9 yards in a future video. So I want you to stay tuned for this, because I'm going to give you a whole bunch of details about USB, and you'll want to know all about it. Alright, I will tell you more in a future video, so I'd like for you to stay tuned.